using a different package. Hopefully we can see all things is okay after. Okay, screen 1, screen 2. Okay, this is here. Probably you can see this. Can you see the PowerPoint? Someone else say something. Can you see the PowerPoint? Okay, perfect. You know, the main reason for this live session was looking at ANOVA and regression models, but you know, I have lots of questions for individual assignment 2 and final exam. For that reason, I'm going to focus on individual assignment 2 with a few examples, and then I will go through the final exam very fast. If we have time, I will be more than happy to discuss about the ANOVA and the regression. You are okay. This is also okay if you want to have any question during my presentation, that's fine. So I'm trying to finish that by 7:30. So if you are okay and we have more time to discuss, I'm available till 8. That's fine with me. Okay, the individual assignment 2, I'm also not using the presentation modes because it limited me by this screen. By now, most of you selected your topic and data set. If any of you are here and didn't find or didn't select your topic, in my class, at least 3 students did not submit. If you did not, please do it as soon as we finish the presentation. Then you need to define a research question you want to address and run the analysis and describe your findings. This is what I expected to see, and I will go through the instruction step-by-step guideline, but very short presentation about that, short slide. There is no need for any literature review. I don't like to see any literature review. The main reason for this assignment is just for you to show how you learn RStudio, how you are understanding the data, how you can describe your findings. If you are working as a managerial job or do you like to apply for that, how the data and the findings can help you. And finally, how do you understand the figures, the plot, what the differences between box plot, density plot, what's the differences between mean, standard deviation, and how we can compute the significant difference between two populations. And if you are only one student submitted a regression analysis for the individual assignment, otherwise most of you submitted a topic with 2 population, and this is completely fine. For this assignment, I don't expected you to go further doing some regression analysis. This is okay if you like to do that. I would be happy to help you, but it's not required for this assignment. And okay, I expected to just start it directly with introduction, just not more than 1 paragraph. Then describe your data and describe the variables you are looking to that. Let me bring you here an example I'm going to share with you. This is it. Okay, this is a sample of individual assignment I like to see. I'm going to share with this after this presentation. I prepared just this afternoon to just share with some of you because I receive lots of questions about that. First of all, you have a title page here, and in title page you have the name of the data, your name, university, professor, HMGT, and date. Also, if you copy this file, this is completely fine. If you copy this file, you don't need to define even the header, something like that. This is ready to go. Introduction, a short introduction, not more than 1 paragraph, to just discuss, okay, why you think this question is important. How do you want to address this question? And so how do you just understand, okay, why the variable you selected is the best fit for that, and how do you want to discuss. Very short about this, and then go directly to the hypothesis or research question. A hypothesis, by default, it's very similar to your topic. For example, if you are comparing, for example, the average length of a stay between critical and non-critical access hospital, the hypothesis is there is no significant difference on average length of a stay. This is, very standard sentence. This is okay if you like to say, okay, there is significant. I do not recommend that, but this is fine. You can just have positive approach. It's not usually good to have approach on your hypothesis, because the idea is there is no significant differences, because any inequality, whenever you say there is significant differences, does mean the mean between one population is different with the mean with the other population. We don't like to see that in the research. We like to see that there is no significant differences between two populations, especially in the social field. But if you go, for example, for a clinical trial, you are okay. There is a lot of noise on background. I don't know who is that, but please mute your phone, your computer. Okay, thank you. Okay, there is a lot of noise in background. Please mute your F Grant 3. Who is that? Okay, who is this? Okay. Okay, would you please mute your computer? There's a lot of sound in background. Thank you. Perfect. Okay. Okay, this is the hypothesis, and then you go with the data. Describe the data you are using. For example, it depends on your topic. Probably you are using Medicare national data by county. You are using Minnesota Hospital Administration admission. You are using the Minnesota Hospital report. Any data set. Please describe your data set. You imagine I'm not in your class, but I'm reading your assignment. So you need to give me some information. If I decided to repeat your analysis, I will be able to find your data set, follow your method, and see the same results. So please discuss 1 or 2 paragraphs, maybe 5 or 6 lines, and discuss, okay, this is the data set. This data set provides some information like this. Like, for example, if you are working in the Medicare national data by county, okay, this data set provides some information on black and white population. The data set provides in the continuous form, is a ratio form. There is a categorical variable in this. If you are using that categorical variable, just okay, discuss that variables. Otherwise, give me some information about the data, and imagine the situation you are describing this data for someone that has no clue with the data. So that should be so much clearer to follow and understand. And then go with the material and method. This is the most critical part of your assignment. First of all, go with a variable. Usually you don't have more than 2 or maximum 3 variables for this assignment. For example, for my example here in the instruction I'm going to share with you, I have 2 variables, average length of stay, and I have a CAH variable, critical access care hospital. The average length of stay is a numeric variable, is term of the continuous variables. The CAH is a categorical variable. The source of data is Department of Health Minnesota. The year of data is 2012. You can also add a note here, source of data Department of Health Minnesota. I still have some background sound. Please mute your computer. Okay, then this is about the variable. So for example, if you are using Alberto, you are talking and we are hearing you, hopefully, or someone else. I don't know who is that, but I can't find. Please mute your computer. Okay, and then you know, the type of variable show the test you need to follow. For example, for the team project, I have a question about the using the chi-square test, for example, for comparing two continuous variable or one continuous variable and one categorical variable. Please remember, for this hypothesis, for this example, or for example, if you are working with a Medicare national data by county and you consider you are comparing the diabetes rate between black and white population, both of them is a continuous variable. They are two population. I'm not looking for kind of a chi-square to compare each observation. I'm looking at them as a two population, black population, white population. So I have two means, I have two standard deviation, I have two numbers, two n, two observation, and all of them is the best fit for the t-test. The question is, do I need to use the unpaired t-test or paired t-test? Do you know what's the differences between unpaired and paired t-test? Anyone want to talk about that? No one? Okay, the paired t-test is whenever two population are exactly same as each other. For example, if you have the data for all black population in 10 counties, and you have data for the same same county for the white, for each observation in one group you have a observation for the second group. For each observation in one population you have exactly the same observation for the second population. This is the place for paired t-tests. But for the community or for the data set like Medicare national by data by county, or for example for Minnesota data, for example, if you have 10 hospitals in 2000 in one county, you have 20 hospitals in the other county. If you use paired t-tests, you know, the RStudio, you're gonna remove any non-paired data, so you're gonna lose a lot of observation. For that reason, for this assignment, please go with the unpaired t-test. The unpaired t-test, ignore the observation, just look at the mean and the standard deviation. For that reason, whenever you have two populations, you are not sure that, please remember, if the observation is equal, the unpaired t-test is going to be very similar or maybe exactly same as the paired t-test. But if they are two different observations, if they have two different observations, using the unpaired t-test is privileged, because you are keeping as much as variable as much as observation possible in your model. Okay, this is for this. And then it was a short description about, okay, what type of the method you are using. That, for example, if you're talking about the t-test, write a short sentence here. I just copy a sentence here from a citation. You can discuss, for example, if you say, okay, this is a qualitative analysis, correct? The qualitative analysis, I expected you just describe 1 or 2 lines and discuss about the qualitative analysis. Add at least 1 citation. If you are saying that, okay, the t-test is the best fit model for this, okay, discuss about the t-test. It's very easy. Just Google the t-test in RStudio. You can see hundreds of citations and just look at them and the best find one of them and then report in your data, in your assignments. This part, okay, so you have, till now we have a variable, we have the method, and we have the data analysis process. And when you have the when you are clear about this, so the next step is just go to the RStudio and run the analysis. I will show that later, but for now, imagine that you have all the information. You run the analysis, you have the means, you have the result of t-test, and you have figures. First of all, you need to look at the distribution of your data, because the t-test is the best fit test for the normally distributed data. And for finding the normal distributed data, there is two options. Actually, I provided two options for you. The first one is look at the density plot. This is almost normally distributed. After 6, there is kind of a tail, but it's a few observations here. Or you can look at the box plot. If you compare these two box plot, the dark blue with the light blue, you can see, okay, except one outlier here for the non-access care hospital, the other parts almost is normal distributed data. If you even look at the box plot, you can see if there was a very long tail here, I can say, okay, this data is not normally distributed. For that reason, you need to look at the distribution of data, and this is the place that, okay, using the Excel is not good fit, because you are not able to see the distribution of data. So for sure, this is okay if you want to go with SPSS. A few of you use SPSS for the team project. This is fine. This is okay if you like to go with a SAS. If you want to go with this data, if you like to go further, go with work with S+, any other data set, that is completely fine. But give me some information about the distribution of data. And then you have a table. The first table report the variables and discuss about that's a definition of the variables. And the second table is a table of descriptive analysis. This is the only part that you need RStudio, and even you can do Excel with for reporting this table. This is fine, but that's not fine for the reporting the plot. You have two variables to group critical access care, non-critical access care, and you have number of observation, you have a mean, you have a standard deviation, and you have the p-value. If you are using exactly the same title, please make sure to check your data. This is an example here. I don't expect that you see the same number in your data set. So please don't confuse yourself and don't try to find exactly the same number here. Maybe this number is correct, maybe it's not, because the data, I don't remember if I filtered the data, if I eliminated the subset data or not, but this is example of table I like to have. I like to see the N or observation here. This is okay if you want to say observation. This is the mean, this is the standard deviation, this is the p-value. The p-values, a few of you reported 2 p-value or 2 t-test for 2 population. Whenever you have 2 population, doesn't matter, you just compare the first with the second or just second with the first. For both of them, even if you switch X with Y in the RStudio, this is the result will not change. For 2 population, you have 2 means, you have 2 standard deviation, and you have 2 observation, but you have 1 t-value and 1 p-value. And I like you to just report the p-value here. And if the p-value is more than 0.05, the result is not significant. If the p-value is less than 0.05, the mean difference is significant between 2 population. And here, look at this, and then you need to discuss your finding. For example, based on this table, I like you to just discuss in 2 or 3 lines and say, okay, for example, the mean for critical access is 550, and the mean for non-critical access is 7,895, with standard deviation. And then discuss, okay, based on the p-value, because it's equal to 0 almost, it's less than 5%, so I can conclude that there is significant differences between 2 populations. This is kind of discussion. You're gonna have this here, kind of result you have here, and then for the discussion, For the discussion, if I don't expect it to see more than 3 or 4 lines discussion, because the discussion is not exactly same as results, but is equal, almost the same as same results, but without any numbers. In team project, probably you read my feedback, because I submitted 3 groups last night and 1 group this morning. If you look at my feedback, for the discussion, you don't need to report the parent, the number, the observation. You don't need to report any kind of statistics. The discussion is the place you want to discuss your finding. Also, it's possible to report kind of limitation for research. I don't expect that you just discuss a limitation, but try to learn. And for example, the limitation for all of the assignment in the class is, okay, this is the student job. There is probably the data. We can go with a difference model. We're just trying to use some statistics here. Or you can say, okay, the limitation, or you can go with academic limitation, okay, and say, okay, we need more further analysis to discuss about this. We did not include any other variables in the models. Kind of, for example, the academic discussion limitation, you can find the paper. If you just look at one of the peer review paper, you can see the kind of limitation. Maybe 1 or 2 limitation, this is okay. Not more than 2 or 3 lines. And then for the conclusion and policy recommendations. For this part, I like to see your thought about the topic. For example, if you are working on the critical care access and non-critical care access, I like to see what you think. If you are in the position of the policymaker, what's your suggestion to improve the access for this example? If you are working with a Medicare national data by county and comparing black and white, and you find, okay, the white people are more likely to use more service than black people, okay, what is your advice for policymaker to reduce the inequality? If you are working with imaging and data set comparing CT with MRI, and you find, okay, more MRI than CT, and the MRI is more expensive than CT, what is your policy analysis? Probably you can say something, okay, we need some kind of cost effectiveness analysis. It's recommended to go with CT. We can go with a waiting list or something like this. This is kind of conclusion and policy recommendation. Again, here, I don't expect to see more than 3 or 4 lines, maybe 3 lines. This is fine. I don't like to see a long discussion, conclusion, recommendation. Just I like to see if you want to report this data, this report to someone in some place that they can make a decision. Okay, they can just read and just understand easily, and then use that for the policy changes. And then please report your references using the APA format. In class, I still see some students don't use the APA format. We are in week 6. I don't expect to see any kind of wrong report for the APA. This is unacceptable, basically, because for first week and second week, this is okay. You are trying to learn, but after 6 weeks, still finding some problem with APA format. This is not good at all. Please use this. And if you are using some citation, any citation in the reference, please make sure you report in text. Sometimes it happened to me. I use a reference, but I forget to report in the text, and so I will back and then report that. There is a very good website in the university, UMUC APA citation. If you just search UMUC APA citation, you can see that. And this is a very, very good website with a lot of example. Any question till now? No question? Yes, please go ahead. Yes, I can hear you. Mm-hmm. Mm-hmm. Okay. You know, usually the RStudio, any number more than 5 decimal reported as a power. For example, that power, sometimes you can see 2.2 on power of minus 26. This is kind of number reported in RStudio. It does mean you have 25, 0, and then 2. That number is more likely close to 0. For those number, you can just report up to 4 decimal, 0, 0.0000, something like that. You don't need to report all the 0. You don't need to report all the power. So any number that you have, when you know, if you receive any power, negative power, you are making sure that number is very close to 0. Exactly. That means that's much more less than 0.05. Any number less than 0.05, it means that at 5% error, there is a significant differences between these two variables. Okay, any other question? Thank you, Emily. That was a great question. Sure. Okay, do you have any other question here? Okay, let me go to the RStudio and then discuss. Can you see my screen very well now? Okay, perfect. You know, I'm going to review 3 examples here with 3 data sets. And let me go back to the PowerPoint because a few points I need to discuss here before going to that. It was, I think I shared with you in the class. Instruction. You know, let me find that. I can find that file. Oh, here. Okay, this is it. Can you see this? Okay. Yes. Sure. Mm-hmm. Mm-hmm. Yes. Yes, I will share with Dr. Azadi and Dr. May to just share with all the students. Are you in which class, Dr. May or Dr.? Okay, I will share with Dr. May. I already share in the UMUC share folder, but I work on this afternoon. So probably if she look at that folder before any time less than 5 p.m. this afternoon, so it's not there. But I will share. I will share with them. And yes, sure. Any material that are providing in my class are available for all of you in any other class. So feel free to ask your professor, and that's gonna be okay. It's completely okay with me, and I expect to have all students from all class receive the same material that I'm sharing with my class. Okay, you know, we provide 3 data set. We have up to 6 data set in the class, but for the RStudio, you need to use a CSV file here. Otherwise, your data sets cannot be recognizable by RStudio, and you're gonna receive a false result. These are the steps you need to follow to, if you are working with Excel. Here is my suggestion to you. First of all, try to use the CSV file I already generated for the class. I generated three CSV file. All the file reported in the RStudio codes. Probably you see this. I think you have this file, correct? I believe you have, what is that? You have this individual assignment to intro. You have this file, correct? sample t-test, sample codes with all the data in this. Do you have this one? Emily, specifically you, do you have this file? Emily, I can. Okay, so you don't have this file. Okay. Okay, I will ask Dr. May to report to just share with the class. In this data set, in this file, I share. Someone else say I did not have that. Who said that I didn't have that file? Okay, who was that? Okay. Codes. Okay, you know, Emily, I just put all of them in together as a one file. Otherwise, even if you have a master code for the team project, this is, or you can just modify that and use for individual assignments. But again, I will share this file with her to share with you. The differences between this file and the file you in the RStudio file, there is kind of link here, and if you press on the link, you can receive the CSV file, so you don't need to follow all of this step I explain here to convert its Excel file to the CSV file. But let me explain here, because if you try to use a different data set, okay, or out of this class, first of all, you need to save as the data set as a CSV file. And for doing that, you know, this is the point. This is the example. This is the example from the Minnesota hospital data. If you look at this Excel file, you have 1, 2, 3 row till find the actual number here. The actual number reported here in row number 5. So whenever you read this data Excel file from the RStudio, the RStudio consider the first row as a name of variables. And if there is no name, started from number 1. For example, the first variable gonna be Minnesota, the second variable is gonna be x2, x3, x4. Each column will be receive x and number, and that's not easy to. And also, because there's kind of a string variable here, a string name here, the data converted to the string data set. So whenever you look at the data, if you don't convert to the numeric, you're gonna receive no observation, 0. And for the no observations, you know, whenever you have a string data, it doesn't matter. It's like comparing two different name. It does, even if this is a number and there is a name on that, the RStudio or any state of any package, statistical package, compared it as a string observation, and the string observation cannot be compared together. The same thing happened if you are not using the separator. For example, in an Excel file, sometimes the separator is activated. For example, 100,000 report as 100, 30, and then if you are reading it directly without removing that, the RStudio consider that as a string file. To avoid that, let me open one of the class data sets and then show you how you can change that. Where is my class? Here. Okay, how can I find that? Let me open from the class. I don't like to type my password here. Okay, it should be okay here. Okay, here. Week 6. This is the data, for example, Minnesota data here. Sorry, class, it's still working on downloading file. Okay. And this is the data set. Come on. Okay, here. This is the data set. This is the file you have in class. So I converted this file to the CSV file, but in case you wanted to convert that, make sure the first line is the only line with the name of variable. So kind of these names. This is so long name, but it's RStudio can read this, but instead of mental health, bracket, psychiatric, administration, you're gonna see something mental health dot psychiatric dot administration. Any parenthesis in RStudio converted to the dot. The name of the data set you can see in the file is like this. The easy way, you can just give a short name for this. If you are working with two different variables, just for example the mental and neurology, you can just go with this, a short name, and then read the data sets. Before reading the data set, you need to make sure that, you know, can you see this divider here? I'm gonna show what's one of this column, and then you are, or maybe I can select all of them. Let's see. Okay, right click here, go to the format cell, click on number. Here, do not do the report, remove all of them, and this is okay. Okay, use a separator. Cannot accept. I have to go step by step with this. Let me go with this too. Numeric or generate. Okay, I go with the general file. Okay, let me explain again. You can select all the file, click on one of the column, go to the format cell, click instead of number, the number has separated with 2 decimal here, click on general. Okay, all of the separator eliminated here. Then you can click on here, click on save as, browse in some place. I usually recommend you go to the CUMUC. I'm gonna call it as a test, and then here you can CSV file. This is the file, comma delimited. Click on this and save the file. Okay, this. Let me close and open the file. If you open this file, CUMUC test. Okay, this is the CSV file. If I read this file from the RStudio, let me read this file from the RStudio. I'm going to read this file. I call it test. CUMUC, correct? This was the name of the file is test. And to see the name of the variables, you can just go with this, correct? Always you can type here. Oh, come on. Names test. This is the name of variables here. See, all of the variables is here. For example, look at this variable. If you look at the file, neonatal care here, neonatal care is something like this. The RStudio doesn't recognize the bracket here. And then this is the file. you can go ahead and use. This is all the name of variables in the data set. You can go ahead with this now. If you don't have a CSV file, make sure to just convert and work with the CSV file. Any question for this part? Okay, we don't have any question here. I'm gonna go with one example in the class. For now, I'm going to work in an example with comparing the Minnesota imaging procedure. The name of the data set is the Minnesota imaging procedure. This is the data set. In my class, it is available from here. What is that? Okay. You can click on this imaging here. If you can click and download this data set. I will ask Professor Azadi and Professor May to share with your class also. First of all, you are reading this data set. You know, in the master code, I add a sync command, but the point is, if you run the sync command, you are not able to see the output in the console panel. We have four panels. One panel, the code panel, data panel, plot panel, and the console panel. If I run this sync, I will not able to see anything here. See, I cannot see the name of file. To see that, you have to close the sync command. For the individual assignment, I don't recommend you to use the sync command, and you know how to silence the code. You can just put the pound sign and it's going to be silent. So then, first of all, you need to read the data set. Whenever you're reading any data set, you can see the result here. I read this data set, I call this data set Minnesota, and the data set is here, 496 observation. You can click on this and see the data set here. I have 496 observation. If you like, you can click on this. You don't need to do that, but this is okay. Then look at the name of variables. Run this. This is all the variables I have. For example, for this example, I like to compare the MRI procedure with PET CT scan procedure. You know, for this exercise, this assignment, you have not more than 4 functions. The first function is a mean function. The mean function is a mean, name of data set, $, name of variable, and for removing all of the missing observation, we can say non-applicable equal to true. So this is the first function, and I have this number. This is the mean. I'm gonna go with the mean for the PET CT. This is the mean for PET CT, and then I like to see the standard deviation. You can run this step by step or run together. I have the standard deviation. Now I like to have a number of observation. You can use the my table command. Okay, first of all, this is the mean function, standard deviation function, and my table command to see the observation. I have 299 for MRI. I have 52 for PET CT procedure. And now I like to test them. I like to see, is there any significant differences between MRI procedure and PET CT procedure? And this is unpaired non-paired t-test, because I say paired equal to false. If you like to use a paired t-test instead of false, you can say true. That's it. Any F is false, RStudio use the opposite side. Any true is a true. You can say false, you can say F. It's easy to go with that. And usually RStudio give you suggestion for what you want to type here. Okay, I'm gonna run this t-test, and this is the result. I believe this is the place for your question. Emily, did you ask me this question about this number, correct? You know, this is exactly the same number. The number is 3.13 e power of 5. The correct, this is here, 1 2 3 4 5 3. This is the number, the real number for this. This is it. So this is less than, I need for first 4 decimal, 1 2 3 4 5. So I'm gonna report that as a p value equal to 0, and it does mean, okay, there is significant differences between MRI procedure and PET-CT procedures. And the MRI procedure, the X here is back to the MRI here, and the Y back to the PET-CT. The MRI is 2048.37, 35, and 657.30, and this is exactly the same mean you have here. So basically, with running the t-test, you can see the mean, but you are not able to see the standard deviation. This is only things you need here. Also, the function shows that our studio used the Welch to sample t-test for this analysis. Now I like to see the box plot here. This is the code for box plot. Usually you can just run all of them together, and this is the plot. I can see there is a outliers here. Okay, because of these outliers, let me explain this part of the codes. You know, this is the function of title function. The main is the title function. If I change anything here, for example figure number 2, you can see any changes here. So the title function can be changes. Something happened to this. Okay, it changed. You can change any number. This is the text. You can change any text. It will not change your codes. Just can change, for example, the title, anything like that. Now I see there is outliers here. I'm trying to eliminate the outliers with subsetting data. This is another function. I see here, okay, if I go with less than 10,000, I can see here there's an outlier. So here for this, I'm gonna go and eliminate all the observation with less than 10,000. And this is a new data set. I have the Minnesota number 1, and I like to see the distribution of data here. Okay, it's much better. I can see, okay, I have almost 2,000 for this and less than probably 500, 600 here. And then I like to see the density plot. So this is the better data if I want to do that, because I like you, if you did something like that, please report in your assignment that, okay, because kind of outliers, I try to just eliminate some observation, and then these lines give and then discuss about that. These lines show the density plot, and the density plot compare the length of MRI and PET scan. As you see here, the density is based on the main data set. This is based on the this is the data set I use for this. The Minnesota number 1 is the subset data. If you like to see the main data set, you can just eliminate this to Minnesota, the original data set. But okay, let's just stay with this code. This plot, let me copy to clipboard to see here. Okay, this plot shows me always MRI is higher, always PET is lower, and there is a tail here. Probably this tail is back to the population size or back to the hospital size. I have no idea about this at the moment because I need to look at the other data set to understand this. But based on this plot, I can say, okay, after 2000 procedure, any procedure more than 2000, probably back to the area with higher population or the area with a higher population size of the hospital beds. This is it, and you know how to copy this. You can just copy image or copy image that, and then go and paste in your document. If you eliminated your data set, try to test again. If I test this again, I see it's still you know, if I tested the new data sets, I have the mean for MRI of 1417 and I have the mean for PET 553, but still it's significant. It does mean there is a huge significant differences between two data sets even after eliminating the outliers. I have 15 minutes. Do you guys continue more than 15 minutes, or you want me to stop here and go for the final exam? You good? Okay, I'm gonna go and review one of the other data set and then go very fast to the final exam. You guys, do you have any other option? Any other suggestion? Okay, I consider this as okay. And okay, the second data set, probably most of you are using Medicare National Data by County. This is an example for comparing eye exam between black and white population. The data set is here, Medicare National Data by County. This is the CSV file. If you are using the file from the class, make sure to convert that to CSV, or the easy way is just use the file I already uploaded in this file, in this document. Run the data sets, and then okay, let me remove this, otherwise you're gonna be confused. I running this data sets, and this is the name of variables. Okay, I have a few observations here, but the original data set included all the observation. This is just for this presentation. Now I like to compare the eye exam between black and white, right? And I see probably there is no eye exam here. If I click on this, oh, it's here. Where is the eye exam? Minnesota data, name of data, yeah. This is the file I'm reading. It's not this file, but I have, because I read this before. This is the data set I'm using for this. Okay. By default, it should be like this, because for now I'm not using this. If I wanted to use this, the name should be like this. Name of this data set, because I generated this data. Look at this. This is it. This is name of all data set here. I changed this from data to this because I'm reading this file. When you are reading the file, you can, this is the R data set. I'm using MND as a Medicare National Data by County. I'm running this, and this is the data sets. Okay. I have percentage of eye exam black. Look at this variable here, percent of eye exam overall, percent of eye exam black. This is it. Make sure to copy this from here and paste, or if you're using this code, this is okay. If you decided to use any other variable, for example hemoglobin between black and white, you can just copy hemoglobin here. Just make sure to type the correct name of the variable, and it's give you the observation. But now let's back to the eye exam. This is the mean, this is the standard deviation, this is the observation, 52, 2100, and this is the t-test. The t-test, Emily, this is exactly the same number. 2.2 e on power of minus 16 is 0. 0.000 60 times, 16 times, and then 2.2. And then 2, not 2.2. Okay, I have 62 compared to 66, and I have the p-value less than 5%, so there is significant differences between these two variables. and I have 62 for black, I have 66 for white, so I can say the white population more likely to utilize more from my exam comparison with black population. And then I'm going to look at the plots, the box plot. In the box plot, I need to eliminate this. In your code, you can remove the bracket and run again here. Okay, it's removed from here. And then I like to compare the density. And as you see, there is no outlier here. I don't need to go work with subset data. And then I'm gonna go ahead and then run the density plots. Very nice shape. You can see here very normal distributed data. Usually when you are working with the ratio, that's really normal distributed data. Based on this plot, let me bring it here, the middle. The red line is the black, the white, the blue is white. As I see here, you know, always not for this part, less than 40%, and after 95%, almost 90, but most of the time the blue line is covered, is over the red line. So it does mean the mean between these two data sets is more likely be with a blue line of white. Also the white is higher. I can see the white has a higher mean also. This is the other findings from this. Okay, this is two example. We have 8 minutes, we can continue to 10 minutes. I'm gonna go stop here and go for the final exam. Do you have any question by now? Okay. Okay. I will share with you, I explained already here. For the final exam, you know, the final exam is combination of 4 weeks exercise. You're gonna receive exactly the same code for exercise 1, 2, 3, 4. You're gonna have work with exactly the same table, but different data sets. So basically the data set for the final exam doesn't have 3030 observation, but has the same variables. Sometimes I tried to I tried to leave a few mistake in the code to fix by you. I had a lot of questions last term, so I tried to fix all the codes. But if in some place needed, you need to fix the code. I can say 99% you don't need to fix any code, but you have the option to fix a code. If you are running several times, it doesn't work, so don't try to fix the code. For sure, the fixing code is not more than 1 or 2 variables. So if you are having problem, make sure you are using the correct data set. The data set has only 2000 observation. So if you're running the codes and the data you see you have 3030 observation, you are making sure you are using the wrong data set. And for example, after table 1 exercise, if you see you have 2000 observation for 2011, 1500 for 2012, you are making sure you are doing mistake, because if the entire data set is 2000, you cannot have the average, the sum more than 2000. So this is the other place you can control. But if you are doing great job with exercise, you're gonna be okay. And I'm sure if you don't have any problem with the exercise, you will not have any problem with the final exam. This is the reason you really need to work on the weekly exercise and individual assignment too, to just modify the code and just find some kind of error, mistake, or something like that. Okay. I didn't try to explain the regression model. There is a very nice instruction. Please look at the instruction. I believe it's here. Let's see, where is the instruction? Yeah, there is a very good instruction for this. In my class, a few students did not submit that. The instruction is really clear and explain every part of the model. For week 5, we have exactly the same regression, but instead of linear regression model, I just try to introduce a logit model, because sometimes you are using with categorical variables, and then the linear regression model is not best fits model. Okay, it's more likely was all of the things I want to discuss with you. I'm here if you have any question for me. No question? Class, if you don't have any question, I'm going to conclude this live session. Today is September 23rd, 2018. We discuss about individual assignment 2. We discuss about the final exam. We decide I will share all the files, all the codes, all the instruction and example for individual assignment 2 with my class and with the Professor May and Professor Azadi to share with you. And feel free to ask your professor if you have any question. In my class, I'm completely okay with that. I'm also available on Skype. If you have any question, that's fine. Please find my Skype is rstudio, zare.rstudio@gmail.com. Find me on Skype and send me a message. I will be schedule a meeting with you, or just send me an email. I will be okay, and then I will inform you to we can schedule a meeting. Okay, thank you very much, everyone, to be here. Fortunately I saved this in a different format. I'm gonna share this live session with you and Professor May and Professor Azad to share with class. Thank you, class, for participating. You're welcome. Sure, welcome. Thank you. Okay, thank you and goodbye.